Hello and welcome everyone. This in this session of geometric dimensioning and tolerancing, we are going to understand different types of datums. Okay, so how many types of datums are there? With the help of example, in detailed manner, we will understand. I will also tell you about datum feature simulator. Okay, and what is a datum feature? Okay, so all these things. What is a simulator? Okay, and how we can lock the degree of freedoms into the with the help of simulator. Okay, data feature simulator. Okay, so one by one we will understand that how we should do this. Okay, so first of all, we will discuss different types of datums. Okay, and in terms of features and feature of sizes. Okay, so which can be taken as a datum. Okay, so one of the very most common type of datum or and very widely used datum, which is a planar datum. Okay, so first type of datum we are going to understand is of planar datum. So in this example, this is the example of the planar datum. Okay, so basically if you have any planar surface, so this is the part. Okay, so we are taking this part many a times. So this is the part and this bottom surface is the planar surface. Okay, in this part, and you want to take datum in the and you can take this as a in the datum as a drawing. Okay, then it is called the planar datum. This datum on which the part is placed. Okay, so whenever we take that planar datum as a primary datum, so if we are taking this as a primary datum, this is a planar datum, and we are taking as a primary datum, that means in the third compartment of the feature control frame, which is for the primary datum, there we are going to arrest that surface to onto the mating part. Okay, so let's say if for this part, if we see that there are all the 6 degrees of freedom, this part can move like this part can move in this direction, in this direction, it can rotate in this direction, it can rotate in this direction also. Okay, so these are basically the 6 degrees of freedom. Okay, so this can rotate in this direction also. Okay, so what we are doing is, first of all, if we are keeping this part onto this surface, so this is a simulator surface. If we are keeping this part onto the simulator surface, so what is going to be happen? We have already understood this concept, but then we are going to rest. Okay, so the surface is going to be made with the surface. Now what happens? The surface on which the it is going to be rest, the part on this surface. So this surface is going to lock the 3 degrees of freedom of this part. Okay, so I have already told you that this for the planar datum, okay, will become the surface which is the origin of measurement. Okay, so from this point, this surface point, this is the origin of measurement also, and the surface is called the simulated datum, and this surface is called the simulator datum. Datum feature simulator, actually an instrument, is called datum feature simulator. Okay, so this in this it is called datum feature simulator. So the surface, the plane created after placing the part is called the simulator datum. So this surface, the plane created after placing the part, one plane is created. Okay, so that plane is called the datum simulator datum. Okay, so the primary surface is the origin of measurement. So what will be the connection of this part and this surface will be the origin of measurement. So this surface will be the origin of measurement. Whenever I keep the planar surface onto the datum feature simulator, it will arrest 3 degrees of freedom. Okay, so I have already in the previous discussion we have discussed, but again I am telling you now. 3 degrees of freedom are, the part cannot rotate like this. Okay, the part cannot move like this in this direction. The part cannot rotate in this direction. Okay, so two rotational movement and one translational movement is arrested. Okay, now this part can move uh, in this direction, it can move in this direction, it can move, and in this is how it can move, rotate. Okay, So 3 degrees of freedom are arrested and 3 are not. Okay. So by placing with the datum feature simulator, we are arresting the 3 degrees of freedom of this part. Okay. So the movement and the rotation are there. Okay. So now if you want to bring this part into a stable condition, let's say, so what you have to do, you have to arrest all the 6 degrees of freedom. So 3 are left. So for that also we need to arrest this surface and this surface connection and this surface and this surface connection. So all the 6 degrees of freedom will be arrested. Okay. Now another type of datum is there. Okay, which is frequently used in it into the industry. Okay, which is a center plane datum. Okay, so what is going to be happen, that means if you take feature of size as a datum. Okay, whenever you take feature of size, I am not talking about feature, I am talking about feature of size. Okay, so feature of size means if there is a rectangular part, then if you want to hold that part, you want to hold with the help of two planes, okay, or two surfaces. Or if you take an example of an industrial vise, okay, if you are holding a part onto an industrial vise, so in that case, let's say this is the example of an industrial vise. Okay, so in this as a data, this then it is called the center plane datum. Okay, so I'm opening the datums over here, so you can see in this part there is a center datum for this part also, and for this I will say vise we are taking. So in the center there is one plane. Okay, so this is called the center plane datum. If I take center plane as a datum, then the simulator will be two parallel planes. Okay, so we are taking this as a plane and this as a plane. So for holding this part, we want two planes. So we are taking on both the side, there are two planes to hold this part. Okay, which is holding the part. If you want to imagine, I've already told you what it is. You can take it as an industrial vise. Okay, which the part is fixed. Now, whenever we take a center plane, it as a datum, it will arrest 3 degrees of freedom. Okay, I will let you know. So whenever I will arrest the surfaces into this, okay, and I will make so in this case, you can see if I take this part. So in this now, the 3 degrees of freedom are arrested. Okay, the part cannot rotate like this. This rotation is locked. Okay, the part cannot rotate like this. So two rotational movement is locked and one translation. In this part cannot move. Okay, so part can move in this direction only. Part can move in this direction and part can rotate in this direction. Okay, only this direction. So while holding a part onto the vise, onto the similar datum feature simulator we are taking, okay, so it is arresting the 3 degrees of freedom with the help of center plane. Okay, now very next frequently used type of datum is axis datum. Okay, if you want to hold a shaft, so what type of datum feature simulator we have to use? So in this case, we will understand. Okay, so this is the part. If we want to hold this part, so what will be the, how we can hold the part or cylindrical part? The datum feature simulator will also be cylindrical in shape. Okay, so the axis datum. So in this, we are considering the feature of size. So for feature of size, we are considering the axis datum. Okay, so whenever we have cylindrical part like this, and this is the axis datum. Okay, you can see this blue line at the center of this part. So this is the axis. Okay, so we have a cylindrical part like this, and this is the axis. We take this axis of the cylindrical part as a datum. It is called the axis datum. Okay, so whenever we have cylindrical part like this, then the datum feature simulator is also be cylindrical. Okay, so whenever we made the axis of this we are considering the datum feature simulator, because it is also into the cylindrical in shape. Okay, so what will happen, that if we are locking this part, let's say this axis and this axis we are meeting, so what will happen, it is locked. How many degrees of freedom are locked in this case? 4 degrees of freedom are logged. Okay. In the previous case, if we haven't done this case, so there are 6 degrees of freedom for this part also. It can rotate like this. It can move in this direction. It can move in this direction. Okay. It can rotate in this direction. It can rotate in this direction. All the 3 degrees of freedom are there. But if we align the axis, if we are putting that onto the axis datum and making it okay, so there are 4 degrees of freedom which are logged. Okay, which are those degrees of freedom? The part cannot rotate like this. It cannot rotate like this. It cannot rotate like this. It cannot move like this. It cannot move like this. Only one rotational movement, which is from the center axis. Okay. If we are considering, so this is how the part can rotate. So you can see that this part can rotate in at the center of its axis. Okay. And this part can move in front plane if we are not considering the friction. Okay. So in this center axis datum, and the datum feature simulator will also be cylindrical. So in this case, we are logging the 4 degrees of freedom. Okay. Or you can considering, you can think of the chuck. Okay. The in which the into the lathe machine that the part is holding. Okay. So it is the good example for this condition for the datum feature simulator. Okay. Because it is the movement is into one direction and the rotation is into one direct at the center of its axis. Okay, so that's the most important case. So this is the example of the axis datum. Now I will also give you one more example, which is the example for the conical. Okay, so if the part is in conical shape, the datum feature simulator will also be conical. Okay, if we want to hold a conical part, the datum feature simulator will also be in a conical shape. Okay, so let's see, this is the part, and if you want to hold this part, so how we can do this datum feature simulator? If we are considering this part, okay, so how many degrees of freedom are arrested? The part cannot move if we are not considering this. Okay, let's say I'm giving some space. Okay, so we have 6 degrees of freedom. Now we have arrested the 5 degrees of freedom. Okay, how we have arrested the 5 degrees of freedom in the conical shape? The part cannot move upward, downward. All the 3 movements are arrested. Okay, because one is smaller, so the part has arrested. It cannot move from inside the part. Okay, so when all the 3 movements are arrested in this part, 2 rotational movements are arrested. The part cannot rotate like this. The part cannot rotate like this. Only there is a one condition. The part can rotate in its axis. Okay, the part can only rotate around its axis. Because in this case also the part, the datum feature simulator will be in a conical shape. Okay, then only it will hold the part and logs the 5 degrees of freedom. Okay, so this is the very important part. Now, this is all different types of datum feature simulator. So these are different types of datum types which we use on a regular basis. There are a lot more other types of datum features, datum types are also there. Okay, so moreover we will discuss in the next session or the another session. Okay, so this is all about the datum types. Hope you have enough understanding of the datum feature simulator and how we logs the or arrested the degrees of freedom. Thank you.